Hello everyone. So today is gonna be our day 16 of the DSA challenge that we took. And the question today is majority element n by 3 times. Yesterday, when we were solving this question, majority elements more than n by 2 times, I incidentally said that I couldn't find any other question that, can be solved with this more. I mean, I cannot recall any question, but little did I know that when I read this question and I implemented on the lead code, right? I implemented and it was getting solved with the same approach. So there are these two questions that can be solved using Moore's, Moore's voting algorithm, and we'll obviously know if any other question comes in this DSS, in this DSS sheet, or else, I mean, if I couldn't find, I can find any other question that can be solved with this. I'll I'll write it in the description. So without wasting any time, let's get further to this question. So the question is that very simple, as it was given yesterday, that the account should be greater than n by two. Today the question says that let's use black, that count should be greater than n by three, right? So count should be greater than n by three. Let's take this example, right? Why am I taking this example? You will know. You will know. Great. So this is the example that is given to you, right? And you need to find all the elements. So probably here we are. All the elements that appear more than n by 3. Now, I need you to understand something, okay? Before even going to brute force or any other approach, you need to know like how many elements can be there, so that there can be a majority element, right? There can be some majority elements. Why am I emphasizing on elements? You will know. Great. So here the length is nothing but two. Okay? If you divide, sorry, if you divide two by three, right, and the floor of it, you will get three, right? Anything that is occurring. I mean, in this question particularly, it says anything that is occurring for V on one, it is the majority. It is a majority element. Great. So it's either one or greater than one, right? That's what it means. So let's just say if I say that hey, one occurs one time, two occurs one time, right? It equals to two. Had had we had we been given one more element, right? Then I mean basically before even I write this, what does this mean? This means that there can be two um, majority elements. Now why do I say that? Because one occurrence, two occurrence. At math, at math, there can be two elements because why is it so? Because the length is two, and once it occurs, it means if this is an separate element, this is a unique element, then only two can occur, right? Great. Similarly, let's divide. Let's take n, which is equal to 8, right? Okay. So if I divide 8 by 3 and take the floor of it, what does it mean? It means 2. Great. So if I say that, hey, I take 2 here, I take two elements of another kind, right? Okay. Mm, how do I explain this thing? All right. Mm, so I'll tell you something, right? If I take two elements, right? I take two elements. Is it a majority element? You will say no, obviously not, because you need more than more than two. So what is the answer going to look like? It will look like either 3 greater than equal to 3 greater than equal to 3. So if an element exists more than three times or more than two times or equal to three times and more, right? Great. So I've written this down. What if What if I add one more element that is also occurring three times? Assuming that it is also occurring three times in the array. What does that length become? It becomes 9, right? It becomes 9. But what was the length given to us? It was given 8. So So I think we can surely understand that at math, two element can be majority element, right? This is, I think, we can understand. Now, why is it so? Because if you take unique elements, right? If in the length of it, you take all the elements that are unique, you won't find any. Great, no problem. Now, if you take, if you let's just say what can be the answer, right? If you take all unique, I can write it here, all unique, right? So, therefore, the answer should look like an empty array. If I say, if I take maybe, 6 elements, same, and two unique, what does this mean? What does this mean? Let's see. It means that there can be only one element that is a majority element, right? Now, if I take 3 plus 3 plus 2, this means that there can be two answers, right? There can be two answers. So 1 and 2. Okay. If I take 3 plus 3 plus 3, you will say, hey, you can obviously say that it can be. And what if I take, all the other permutations you can find, like 3 plus 1 plus, you know, 2 plus 1 plus 1. I mean, you can go on and on. But here you will find that only one element is occurring more than or equal to 3 times. So again, the answer will be 1. So I think we have already proved that hey, there can only be two elements maximum in every length. In for all the lengths, you can take any random length and you can divide it by 3, take the floor of it, and then you can have all the permutations and combinations. Great. So I think we have understood that only at max there can be two elements. Answer should be equal to this. Now, what if I copy this, right? What if I copy this? I'll take this here. Great. Now, what will I say? I will say that for brute force, brute, right? Great. So I will start my I loop from here. I will start my I loop from here. Okay. I will say that hey, I is equal to, I is 3. So count is equal to 1, right? Then I will start my J loop from, I can start it from here. I can start it from here, wherever you like. So yesterday, when I was making the video, I think I said that you can start it from I plus 1. And then I was deep down in my thinking that should I have started it with I plus 1 only or should I have started it with 0? See, I will tell you one thing. I saw Skyver's video, right? And he said that you can start it from 0, right? But then I figured out that it doesn't really matter. It doesn't really matter. Any element, if it occurs here, right, and you are thinking of a use case that hey, if it occurs here, and it should have, if I start from I plus 1, basically here from here. If this is your I and you start from here, there is no way that if the element had occurred before I, let's just say 2 had occurred before, first position, that is array of 1, right? If it had occurred at array of 0, or if it had been a bigger array and it could have, occurred I minus 1, then we have already counted 2 since we are starting from I plus 1. So it doesn't really make sense to, start from 0. You can start from 0, there's no problem in it, but it doesn't really matter. It doesn't really matter. Great. So you can start I from, 0 and j from I plus 1. And then you can count how many threes are there. So there are, you will find that if j is j3, you can start from I as well, no problem. But we have already encountered since a of I'll initialize count as 1. So you can start from here. But 2 is not equal to 3. You will go ahead and you will increment your count because 3 is equal to 3, right? So again, then you will check because you are learning a for loop starts from 0, goes till n minus 1. You are initializing count is equals to 1. Then you're starting your J loop again, which can start from I plus 1 and, goes till n minus 1. If array of I is equal to, um, you know, maybe array of J, right? You can say count plus plus, and you can check here. You can probably if you check here that if my count is greater than math dot floor of n by 3, you can have what you can do is you can have let's say we have an answer array which is initialized at empty. You can say that here answer dot push array of I. Great. If this is the if this is the true situation, you can if this is the true situation. Now, what if I tell you? What if I tell you that why will I tell you? You already know that time complexity is since we are running two straight loops, though it's starting from I plus one, but again, in the worst case, it is running for O of n plus, in the worst case, it is running for O n minus one. Since, if you consider the first element, then it is starting from O. It is running till O n minus one, doesn't really matter. In the worst case, I'm talking about. So it's nothing but O of, sorry, this should be multiplied. It should be O of n squared, since you do not consider any, any constant. Space complexity, see, depends. If if in the question only you are written that find all the elements. See, in the question you are O of one space. I think see here when you move to here, right? It probably means that you have to can you check your return type should be an array. If you check here, your return type should be an array. Great. So basically, what you're doing is you are not taking any extra space just to solve the question. You are taking an extra space to return the answer. So that is acceptable. See, you can mention in front of it you that code. You can mention that hey, if you consider the answer as as an extra space, yes, I'm taking an O of n slash I'm not taking any extra space, right? If you consider it, if you consider my return type as an extra space, yes, I am using. But else I'm not using it to solve any my query. I'm not using it. Again. See, this was O of n squared. Your um, interview might say that hey, I don't want it. What you can do is you can go on to a better approach. Now, what is a better approach? We discussed yesterday also. Same approach, right? The hash map or the object, right? Object. Great. So again, I will paste it here. What will I do? That hey, see here, okay. See, this is my object. No, it's an empty object. Great. Next, two. Two is one. Sorry, right? Again, now comes three. Three becomes two. Great. Now what I'll do is this is my object when I've uh, traversed it. Now what should it look like? It should say that hey, I will traverse my whole object again, and if I traverse my object again and find what is the value. So if value is greater than n by 3, then I will add it in my answer. So if I initialize answer as an empty array, then ans dot push object of whatever. Um, Maybe when you are running basically what I'm trying to say is you can push the key of that object, right? Great. What is the expected time complexity of this particular algorithm? It will be O of n for traversing the whole array and adding in the object. Great. It is O of n to, basically, maybe you can say O of m or n, whatever. First case, it will be n only because if all the elements are unique, then it will be O of n only. Then you can say O of n for traversing the whole object, right? So it becomes 2n or O of n only, whatever. Space complexity, you are taking an extra space of an object and you are, you know, basically you are taking an extra space to solve your question. Now here it is saying that here you are solving your question and what you're doing is you are, taking an object which solves your problem and then you're returning it in an array which might or might not be considered as an extra space. It's fine. Great. So I can say that here this is given O of n. Now I think this line, this follow-up question is for this O of n, right? This O of n that you don't need to have an hash map or maybe an object for that matter, right? So again, we have solved it in a linear time complexity, but we've still used an extra space. Now comes the optimal, and I'll tell you something. I'll tell you something. Optimal. The question, the query that we ran yesterday, right? The Moore's algorithm, the Moore's voting algorithm, we'll be using that only. We'll be using that only. Now I will implement something. I will write down the code. Let's just say if I, you know, go here, this is the yesterday's question. If I copy it, right? If what I can do is I can copy this whole thing up. I can paste it here. Let it be in red color, right? Let it be in red color. What I can do is I can delete this and this comment. I don't want it, obviously, you know, so as to say here, right? Okay, what I can do is I can delete this line and this line because we already know that's the part of the um, you know, function, right? Now what I can do? Now you see what I can do. This question was to find only one majority element, right? This was question was only to find one majority element. But in the question that we're going to solve today, the variation of this particular question, it might have two solutions. It might have two solutions at max, although it is the maximum that it can have, but it still can have two things. That means we need to consider two counts and two elements, right? What we can do is you can write it like this. What if I start from here? That hey, count one equal to zero and count two equal to zero. Again, let element one equal to something and element two can also be defined. You don't need to give it any. Yeah? You can give it any random value or what you can do is you can, you know, just initialize it. And then we can later on give its value. Great. Let's start a loop. Let I is equal to 0, I is less than n, I plus plus, assuming n is the length, right? Great. Now I will check that, hey, if count 1 is equal to 0, then I will say that, hey, what you can do is you can say that element 1 is equal to nums of I and count 1 is equal to 1 or count 1 plus plus. Else if count 2 is equal same for the second element, obviously, right? You can say that element 2 is equal to nums of I and count 2 is equals to 1. Great. Else if now at this part of we have this, what does this part do? This part says that hey, you need to add your uh, you need to initialize your element. Great. Or you need to consider a new element as your majority element. You need to think of a different potential majority element. We have done that for both the things. Great. Now comes when if the element is found to be, it is found in the array, you can increment your count. Great. Let's try to write that. Let's try to write that. So if count, sorry, if nums of I is equal to element 1, then you will say that, hey, count 1 plus plus. Again, and if for second element also nums of I is equal to element 2, then count 2 plus plus. Great. Um, so what does this part do? What does this part do? This part increments the count. We have already done that. This is what it does. Great. Now what is there? If the element is not equal to your element, basically if the current element, that is the array's element, is not equal to your element, not equal to element 1 or element 2, whatever, you can obviously you can say that, hey, just decrease it. So else, just do one thing, count 1 minus minus, count 2 minus minus. Great. So we have done our solution. See, here, right? It is not mentioned. It is not mentioned that, it is not mentioned that every time the element will occur, element will be a majority element. So what we can do is we can again have a check here. So I'll say that check if the element 1 and element 2 are majority L or not, right? We can have a check. We can have a check. Although when I was solving this question, I could not find any, any use case. But again, basically, you don't know if any test case is the one that is checking this thing. So you can have a check here, like we discussed yesterday. And when I write the code, I'll let you know. It's very simple. You will run a loop and you will check that if element 1 is equal to nums of I, then you can say that, hey, count 1 plus plus. Else, if nums of I is equals to element 2, then you can say count 2 plus plus. And you will check for both. If count 1 is greater than n by 3, add it into my answer. If count 2 is greater than 3, n by 3, you can add it into my answer. Basically, this is the thing. When this should ideally run, right? This should ideally run. What are we doing? We're just doing it for two elements. Now we know that at max there can be two elements. But to your surprise, this approach will not. This approach will not. Let's try to think of it. Let's try to think of it. So where is my answer? Here. This is my query. Let's try to paste it here. Right? Okay. Uh, count again. It is 0 0. Yes, right? Count one is if count one is 0. Yes, it is 0. Element one will be number 5. So what does element one become? It becomes 3. What I can do is I can take a number. Right? I can take a number. So it will be 3. So element 1 becomes 3. Count is equals to 1. So this becomes 1. Now, you know all these are if and else conditions. So if 1 is executed, then it will go back here. Go back here. Now I becomes 1. What is at 1? This is 2. Great. Um, Else if element 2 is, or maybe what we can add is, I'll read into my nums, right? I'll read into my nums. You don't have to worry about it. Else if else if count 1 is equal to 0, no, it is not 0. So this will run count 2 is equal to 0. Yes, element 2 becomes the nums of 5. So it becomes 2. Again, this execute. Why will it execute? It will execute for the matter that this is 3. Now count 1 is not equal to 0. Count 2 is not equal to 0. If nums of I is equal to element 1, yes, it is. Count 1 will be increment. This runs for this. This runs for this. Now consider mm, this being our example. Although it's a very small example, will it create a problem? Let's see. Okay. Again, no, it will not, right? It will not. Mm, okay, what I can do is I can, so let me delete these things and let me increment it. What should I do right now? This is 2, fine. I can add one more, that is, maybe again, let's just say if I add 4 here and maybe a 3 again. I think this should ideally solve my problem. Basically, what I'm trying to explain to you guys, right? This should solve it. So till here our count one was two and count two was equal to one, right? Because at this part we did this, right? Now we move to four. Great. Now here four. Is count one zero? No. Is my count two zero? No. If count one is equals to element one? No. These also no. So this thing will run. So this becomes one, and this becomes zero again. This becomes zero again. Great. Now I move to this part. I will say that hey, if my count one is equal to zero? No. If my count two is equal to zero? Um, See, it is zero. It is zero. Yes. So element two also becomes three. Do you notice something? It also becomes three and count two becomes one. Now both my elements, one and two, are pointing to the same thing. Basically are checking. Let's just say if it had more elements, right? If it had more elements, both of the things will check same thing. That is, if the elements are equal to three. Are we considering then are we considering all the elements? Are we making sure that all the potential elements are covered in it? No, right? No. I need to have a check here that hey, element one and element two should always be unique, because I need to find all the unique, basically the what do you call unique majority elements. So after it, I am checking that hey, if they are majority elements or not. But I am still, if at this situation, right, at this situation, both of them are three, I am losing on a lot of potential element that may or may not be, a majority element at the end of the day or not. So what I'll do, I'll simply, I'll simply have a check here, right? I'll say and add, no problem. My element two, my nums of I is not equal to element 2, right? It is not equal to element 2 because my element 1 should not point to element 2 again. I mean, they both should not be equal. And here, I'll say that, hey, nums of I, you should not be equal to element 1. Then only I will mark you as a unique majority element. I think we have written our code. I think this is good to go. Let's try to copy this. Let's try to copy this. I will try to paste it here. I will say one thing. Let this, let this, and let's take n, which is nothing but nums of length. Great. Okay. And what I can do is, like I said, let's check if the element found are majority element or not, right? So I can say that, hey, let answer is equals to an empty array. Great. For again, I'll start my loop from zero. I'll go till, simply n I plus plus. I'll say that, hey, if, I'll say that, hey, count one is equal to zero now. And again, count two is also equal to zero. I'm again giving the value to count and count 1 and 2 as 0 only because I need to reinitiate the value. So if I'll say that, hey, if nums of I is equal to element 1 found, I'll say count 1 plus 1. I'll say check if nums of I equal to element 2, then count 2 plus plus. Great. I'll check. I'll check that, hey, if my count 1 is greater than math.floor of n by 3, right? I will answer dot push my element 1 because count 1 basically represents the element 1. I'll copy this. I'll say that, hey, this is going to be 2, and if count 2 is greater than this, I can say answer dot push. And at the end of the day, let's get out the answer. Let's try to run this and hope that it runs in the first time. Great. Doesn't run. Wow. Why doesn't it run? Let's try to check. Let's try to check here. Okay, okay. Again, you know what I do, right? If I find the question to be not equal, so I will go to Python tutor. I will try copy this. I will say that a majority element, maybe um, let's pass 3 to 3, and let's console this. I am probably making a very silly mistake, and let's try to find what that silly mistake is, right? Okay, no problem. Okay, element 1 undefined. So if again, what is the problem? I is equals to 0, count 1. If count 1 is equal to 0 and hey, why is it so? Okay, probably I have already found. What is it? It is math.length. Sorry, nums dot array dot length and not this. Great, accepted. Did you see how I could find it out? That see, the point is that this loop is not running at all. Now there must be a problem in n. It is not checking you need using n. And if you check what n is, there is a typo here. There's a typo here. I'm not sure why this didn't throw a message because nums has to be maybe it's JavaScript and not TypeScript. Had it done it using Java TypeScript, it would have given me a you know. Or can we find the object length using obj.length? Not sure. Not sure. I'll have to check. Okay. Okay. Fine. This is accepted. Let's try to submit, and you will see that this is accepted. Great. This is accepted. I have discussed the intuition, like why is this solution going to run. Basically, I've told you in my previous video that this is the Moore's voting algorithm, and this why does it run. In your previous video, you can go and check it out there. You can probably go and find out why this will consider every element to be a potential majority element, and same are we doing here also because we have already figured out one thing, and that is that there can be at max two elements that are a majority element. So that is why we are taking two counts and two elements, right? Two EF basically. Great. We have solved this question. Let's try to write some note here. You need to use Moore's voting algorithm only, but you need two counts and two elements since at now only two elements can be majority element greater than n by 3. You need to modify your if and else condition to reach the answer, you may have to run a loop to check if the majority elements found are even the majority or not, since in the question there's nowhere given that majority element always exists or two exists every time. Now, what does this line mean? Now, what does this line mean? You could figure out here. You could figure out here that when we were running our majority, okay, let's do one thing. I'll show you something. Let me console log something, right? I'll say that hey, element one, you also get console, and you also element two, you also get console. You will notice one thing. You will notice one thing for sure. Element one is three, and element two is three, right? If you run the loop in your mind, you will notice that count two never became zero. Count two never became zero because count one becomes one, count two becomes one, count one becomes two. But we never reached this piece of line, right? This else condition we never reached in this particular. So had I been, had I returned the answer as three and two, it would have been wrong, right? I still need to check. So that is why you need to always check that here it is never given that every time two only exists. You will say that hey, I have to check. So let's try to save it and let's mark it as done. Great. We have successfully done day 16. How many is it? So 16 divided by 30. So it's 53%. Great, not bad. So you will notice that 50, we have done 53%, 53.33% of our challenge. Great. Thank you so much, guys, for joining in. I'll see you tomorrow with this question called Grid Unique Paths. This question is going to use DP a little, and you need to know what dynamic programming is. I'll try to. Tomorrow's video, I think, is going to be a little longer than I would have expected. And we'll see tomorrow if we need. I'll try to see in my offline time that should I consider this question, because I think this uses math as well and not entirely DP, right? So DP is one of the optimal solution, and there is an optimal solution which uses math, not entirely dynamic programming. So we'll see, right? So thank you so much, guys, for joining in. I'll see you tomorrow with another video. Bye bye.